If you've ever used a GPS, you know that it renders images and draws lines between locations. But how does a GPS do these tasks simultaneously? With threads. Let's define some vocab. A thread is a task that is part of a process, and in this case, the process is Google Maps. The operating system, or OS, is the software that manages threads. The central processing unit, or CPU, resides in the computer hardware, and its job is to execute these threads. Each CPU has the ability to run a single thread, meanwhile pausing and transitioning between other threads, giving it the appearance that it's running multiple when it actually can only focus on one thread's execution at a time. This implies that a multi-CPU design can run multiple threads at once, with each CPU switching back and forth between threads. But how does this actually happen? Well, let's imagine a restaurant with two chefs, Sam and Joe. Each chef can work on one order at a time, and the head chef, Bob, places higher priority on orders that take longer to cook. As with computers, each chef represents a CPU, each order represents a thread, and the head chef represents the OS. Now, an order can wait for an available chef, be serviced by a chef, or postponed because another chef is using the same ingredients or kitchenware that the order requires. Likewise, a thread can be in a ready state, waiting for CPU time, a running state being executed by the CPU, or a block state, where the thread attempts to acquire an object already being accessed by another thread, but needs to wait for the object to be released in order to make any progress. Our first scenario is that there are more orders than chefs. Let's say that 3 orders come in, a burger, a pizza, and a taco, with 2 of them assigned to Sam and 1 to Joe. First, Sam will make the burger because it has a longer cooking time, and Joe will make the taco. Similarly, in computers, the OS schedules the higher priority threads to run first. Now let's say that Sam and Joe both finish their order. Sam will move on to the pizza, but what if Joe gets a pizza order too and then a taco? Even though the pizza is a higher priority, it must enter a block state because Sam is using the ingredients and kitchenware that Joe needs. So now, because the taco is in the ready state, the head chef tells Joe to switch to that order to use his time efficiently. Since Joe is switching orders, the info of the pizza order, like the number, state, and priority, must be saved. Similarly, the OS performs context switches to multitask, and when this happens, the thread's ID, state, priority, and other info are stored in a data structure called a thread control block. This ensures that the CPU can resume running the thread where it left off. Our second scenario is that there are fewer orders than chefs. Let's say that Sam gets an order but Joe doesn't, so he goes on break. Later, more orders come in that Sam can't prepare in a timely fashion, so he leaves to tell Joe to return. He finds Joe asleep and taps him on the shoulder. Likewise, CPUs enter a temporary sleeping state when there are no threads to process, but if there's a CPU awake and threads in the ready state, it can initiate an inter-processor interrupt to wake up another CPU. Overall, multithreading enhances the concurrency and responsiveness of a computer, thereby improving the user experience.